In this part of the unit electrostatics, you will learn about capacitance of a parallel plate capacitor with a dielectric slab inserted in between its plates. What are dielectrics? These are insulating materials. Their molecules get polarized when placed in external electric field. That means electric field can be set up in dielectric materials, but these materials cannot transmit electric current. Electric current cannot pass through these materials. These are of two types: non-polar dielectric materials and polar dielectric materials. H2 and CO2 are the examples of non-polar molecules. These are non-polar molecules. Why these are non-polar molecules? Because the center of mass of positive charges coincides with the center of mass of negative charges in case of non-polar dielectric molecules. You can see in this diagram, the center of mass of positive charge is coinciding with center of mass of negative charge. So net electric dipole moment vector is 0. And in absence of external electric field in these molecules in that sample is also 0. Net electric field in any dielectric material having non-polar molecules is 0 in absence of external electric field. Let us see what happens when external electric field is applied. The centers of mass of negative and positive charges get separated by a certain distance when these non-polar molecules are placed in external electric field. So net electric dipole moment vector is set up, that is non-zero. So electric field is also non-zero in non-polar molecules when these are placed in external electric field. Now polar molecules, we will see the case of dielectric materials having polar molecules. So HCl and H2O are the examples of polar molecules. These molecules are having permanent electric dipole moment vectors. Means their centers of mass of positive and negative charges are permanently separated by a short distance. But in any sample, in absence of external electric field, net electric field developed is 0. Why? These individual dielectric molecules, these individual electric dipole moment vectors are randomly aligned. These are randomly oriented. So net electric field due to these all molecules in any sample is 0. What happens when this sample is placed in external electric field? Individual electric dipole moment vectors get aligned along the direction of external applied electric field. So net electric field becomes non-zero. You can see this dielectric slab is placed in between the plates of this capacitor. You have studied the principle of capacitor. Capacitor is a charge storing device. Why this dielectric slab is introduced? So that it could reduce its potential. To enable it to store extra amount of charge. How it reduces its potential? You can see these individual electric dipole moment vectors are aligned, are directed along the direction of applied external electric field. But internal electric field developed in the dielectric slab is opposite to the direction of applied external electric field. So net result is that electric field inside this slab is reduced. This reduced electric field will reduce the potential of these plates. If potential of these capacitor plates is reduced, that can further be charged. So that's why dielectric slab is introduced in between the plates of the capacitor. C0 is the capacitance of the capacitor having free space in between its plates. Each plate is having area A and the separation between the plates is D. C naught is equal to epsilon naught A by D. One plate is having its charge plus Q and other plate is having its charge minus Q, and E naught is the electric field in between the plates of the capacitor. This is E naught, electric field, shown by these red lines. This is electric field in between the plates of the capacitor where there is free space, and dielectric slab is partially filled in the thickness T in between the plates of the capacitor. This electric field E naught is acting as external electric field for this dielectric slab, and as the result of this external electric field, internal electric field is set up in the dielectric slab, that is EP. It is directed opposite to the direction of applied external electric field E naught. The net electric field in the dielectric slab will be E is equal to E naught minus EP. Now what will be potential difference between the plates? Now there are two cases. One case where dielectric slab is there and the other where free space is there. In T minus D thickness, free space is there, so E naught is the electric field intensity in that space or in this thickness, and in T thickness of the dielectric slab, electric field intensity is E. So V is equal to E naught T minus D, E naught times T minus D plus E into T. Now in first chapter you have studied dielectric constant of the medium is defined as E naught by E. If any source charge Q is there, point charge at a distance R, electric field intensity in free space is given by 1 by 4 pi epsilon naught Q by R square. When this source charge is placed in any medium having dielectric constant K and permittivity epsilon naught K is equal to epsilon, then this electric field becomes 1 by 4 pi epsilon naught K Q by R square. The relation between E and E naught is that E naught by E is equal to K, or E is equal to E naught by K, that E can be replaced by E naught by K. So you get V is equal to E naught times D minus T plus E naught by K into T. E naught can be taken out, so within the bracket we get D minus T plus T by K. In between the plates of the capacitor, electric field, as you know, is equal to sigma by epsilon naught. What is this E naught? Electric field intensity is equal to sigma is charge per unit area, Q by A epsilon naught. So replace this E naught in this expression. We get V is equal to Q by A epsilon naught D minus T plus T by K. Within the bracket D minus T plus T by K. Capacitance C is equal to Q by V. Put up the value of V in this relation. You get C is equal to A epsilon naught by D minus T plus T by K. This is capacitance of a parallel plate capacitor which is partially filled by a dielectric. So its capacitance increases by filling it with dielectric material. Capacitance means the charge storing capacity of the capacitor increases. Now one special case is there when entire space in between the plates of the capacitor is filled up by the dielectric material. That means when T is equal to D, in that case C is equal to K times epsilon naught A by T, that is C is equal to K times C naught, K C naught. That means the capacitance of the capacitor is increased by K times. This is all